Okay, Rams, Miss Moreau is not here today, so we're going to do some practice to help you get ready for your test that's coming up on Wednesday. We're going to work through some problems here, but anything that you have left will be your responsibility to finish for homework. Okay? First problem here says, write the number in expanded form and solve. Okay, so 2 to the 5th power, that 5 is the exponent, so it tells you that there are 5 2's that I'm multiplying. So it is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 of those. Now I need to solve it. Well, I know that 2 times 2 is 4, and 2 times 2 is 4, and then another 2. So 4 times 4 is 16, times 2 is 32. Remember, we never, ever, ever multiply the base times the exponent. Okay, we're going to skip down here. Okay, the opposite problems that we don't do here, you'll do for homework. All right, we're going to skip down here. It says 8 to the 2nd power. Now it says write the number using, the same thing, solve it here. Okay, so 8 to the 2nd power means 8 times 8. There are 2 8's there to solve. 8 times 8 is 64. Now, the next one's a little bit trickier. This is 1.3 to the 2nd power. You'll be able to do that one. Okay, next, right down here. What is the prime factorization of 150? Now, remember, prime factorization, factor as in factor tree, and prime meaning I have to find all the prime numbers that multiply and go into it. So, 150. Okay, what goes into that? Well, I noticed that it ends in a 0, so that tells me it should be a 10. That's what I start with. But there are other ones. You could choose 30 times 5 or 50 times 3 or 2 times 75. But I'm going to do 15 times 10. They are both composite numbers, so I keep dividing. 15 is made up of 3 times 5, and they are both prime. 10 is made up of 2 times 5, and they are both prime. So now my answer here, I take my numbers, all the prime numbers that I circled. Remember, I only circle the ones that are prime, and I write them in numerical order. So 2 times 3 times 5 times 5. Well, I have 2 5's. That means it is 5 to the 2nd power. So 2 times 3 times 5 to the 2nd power. And which of my answer choices look like that? It's this one. Okay, so you do the next one down here. Okay, I'm going to come right up here. This one, order of operations now. 4 to the 3rd power divided by 8 minus 4 plus 1. Okay, remember we don't call it PEMDAS, we call it order of operations. Okay, first thing is I look inside my parentheses and I have 2 different steps here to simplify. I see an exponent and division. But remember, when I have a number, like some information on top of that line, that's like it's grouped all on its own, and then we divide. So this means 4 times 4 times 4. Well, I know that 4 times 4 is 16, and 16 times 4 is 64. So I'm going to use that. Okay, so I'm going to say 64 over 8 minus 4 plus 1. Okay, now I have parentheses, and I have subtraction and addition. Well, I know my order of operations says I need to do parentheses first. So 64 divided by 8 then gives me 8 minus 4 plus 1. I can drop these parentheses now because there's nothing left inside of them to simplify. Now, this is one of those examples of why we don't say that other word, that P word, because that would imply that adding comes before subtracting, and that is not always true. We have to go left to right. So 8 minus 4 is 4, plus 1 is 5, and that is your answer. Okay? All right, I'm going to let you do the next one, and then I will do the one after that. Okay, so I see dividing and multiplying and adding and exponents and subtracting and dividing. But my order of operations tells me to do dividing first, or parentheses first, so which is your dividing here. 18 divided by 6 is 3, so I rewrite it just the same way. 1/2 times 6 plus 9 squared minus 3. Now I'm going to do exponents. 9 to the second power is 81. It's not 18. It's not 9 times 2. So 1/2 times 6 plus 81 minus 3. Okay, now I have multiplying, adding, and subtracting. I'm going to go with multiplying next. 1/2 times 6. That is the same thing as 6 divided by 2, so it's 3 plus 81 minus 3. 3 plus 81 is 84 minus 3. My answer would be 81. Okay, the next problem here you're going to do here we go. Which of the following expressions is equivalent to 5x minus 2x? So this is saying 5x's, and I'm taking away 2 of those x's. So like we did the other day with our models, we have the algebra tiles that we call them here. 5 of these algebra tiles, and I want to take away 2 of them. So if I take those and take them away, or if I think about it as like 5 apples minus 2 apples, I'm left with 3 of those x's here. Okay, I'm going to go ahead and work through all of these on the back page because I know this is kind of new in our class and they might be tough. Okay, which of the following expressions is not equivalent to 5x? Okay, so for each one of these, what I do is I go through and I rewrite them and combine like terms. So 6x plus 2 minus x plus 2. Well, I have 6x's minus 1x, that's 5x's, good, plus 2, oh, that's plus 4. That is not equivalent. But let's look at the rest just in case. 5x's, that's good. Minus 2 and plus 2, that means they cancel each other out. So that one is true. Minus 3 and plus 3, they cancel each other out. And minus 8 and positive 8, they also cancel each other out. That one was kind of easy. All that was left in each of those was just a 5x. Okay? And the last one here, which expression is not equivalent to x plus 3? Okay, these are very straightforward. Okay, what is 12 minus 9 is 3. So I'm left with x plus 3. 5 minus 2 is 3. X plus 3. 3 minus 6 is a negative 3. So that would actually end up being x minus 3. That gets tricky. Okay, and then negative 1 plus 4 is a 3. So that would be x plus 3. But the one that has the negative 3 is the one that changes that operation, and it changes the whole solution there. Okay, so now you will have your practice work to do for your homework tonight. Okay, any questions that you have, make for sure you come in with them tomorrow to class so we can go over them.